So, welcome everybody. Here we have Cynic. He's a computer scientist from Washington, and he actually lives in Milan, where he works for the Hermes project for digital human rights.
See?
Okay, so welcome, Cynic.
Awesome. Okay, so GlobaLeaks. I think most of you are familiar with this project, but for those, for those of you who are not familiar, this is a project. This is really a platform that anonymizes whistleblowers as they transmit information to organizations. So it's kind of like WordPress, but it is a website that runs on as a Tor hidden service. So we've seen over 25 different, I think it's closer to 50 now, but we've seen many civic organizations and civic society use this tool to collect information from whistleblowers and do interesting things with it. Either take data public, challenge their states, or promote transparency. At this conference 5 years ago, actually, this project was started. So I'm not sure how many of you were at ESC 5 years ago. Is there anybody? No. That's fantastic. Nave, this guy was. But 5 years ago, Arturo Filastro actually announced. We did a presentation and they announced the founding of this project. Very interesting. Now, 5 years ago, there was kind of a different approach that was taken, and the thinking was GlobaLeaks was going to be a tool to not aggressively, but get information to targets via a web portal. So you hand somebody a link, and it's kind of a trolling idea, but it's very entertaining. You give somebody a link with information that may or may not be something they want to see, but if you can sort of bring them into the leaking process, maybe you can generate some form of activism. Today, we've not moved on, but we've changed the freaking dialogue, and we're looking at providing manuals for the people who use the system. So what's happened is, as this project has grown, we've seen, we're trying to support more and more users and more different use cases for a tool for whistleblowing and a tool for taking information from sources who want to stay anonymous and keeping them anonymous for as long as possible so we can process that data safely. So it's interesting. So what we're looking at today is more changes to the system, and specifically we're looking at moving the encryption that we've previously done on a server into web browsers to protect data at rest. The idea here is that in the current system, organizations that have non-technical folks, that have journalists, that are that are governments, that are corporations, either have stringent requirements for handling data or installing new applications. So what we're trying to do is provide a complete solution for whistleblowing. So what that means is we want to get rid of a requirement that we have, which is a dependency on using GPG or a custom tool that sits on a recipient to information, a recipient's computer. So this is a specification we've been working on for the last, originally it was like 2012 we started talking about this, and we started implementing it in December of 2015. We're at the point now where we're trying to put this in front of people. We're trying to put this in front of you guys, describe it well, and see if there are problems with this approach. If there's problems, if there's weaknesses, and this is the part where we defend it. We defend our choices, and we say, okay, this is actually an active change. This is new cryptography, and we think it's secure. So with that said, what are we doing? Basically, the goal is for a whistleblower to store nothing in their browser. So we're performing encryption in the browser, and we want that whistleblower to have no information stored in their browser. So they take a secret away. Once they generate a submission, once they send files to us via Tor, or via HTTPS, or some other transport, they walk away with a single piece of a single authentication token. It's something we call a receipt. Said this already, and additionally, we want the ability for the organizations that are taking this information or receiving this information to be able to add new recipients to submissions that have been created. So if you are, the Authority for National Corruption in Italia, maybe you have turnover of handlers who, or you have a review process where somebody at the top of your organization takes submissions and says, this is for this team, this is for this team, this is for this team. And we want to handle that in cryptography, not through some access control system. And finally, for the deployed systems out there, we want to try to support an upgrade that lets them take the version of GlobaLeaks we have deployed today and upgrade into this new system. Okay. So I'm just going to walk through the use case here because why not? So we get a whistleblower. He's somebody who sees something wrong. He's somebody who cannot or does not want to or has tried the traditional channels within their organization or within their environment and has said, I can't go public with this information in this way. I need to remain anonymous. I need to use a tool like GlobaLeaks. Maybe he reads the manual, not a requirement. After figuring out who to talk to, he can connect with either a normal web browser. It actually depends on the configuration of the service that's running, but either you can connect with a normal web browser or a Tor browser via a Tor hidden service. Once that connection's established, he uploads files, he answers a questionnaire, and he's issued a receipt. After that has happened, the organization is basically, it's like a content management system. GlobaLeaks is a content. I mean, you see a submission, and the organization can follow up. And we find this is very important for groups that actually want high quality and feed. It's a process. It's not just dump a bunch of files and walk away. So we try to support this. We try to support this use case of having comments and messages and the ability to handle the relationship of a whistleblower with that organization. And after that submission has been created, after that conversation has occurred, the organization decides what they want to do. And they don't, this service doesn't provide any ability to take that information and publish it on the web or publish it on a torrent or put it on IPFS. It's just internally. It's just an internal system. Once the whistleblower has come in. So what is actually happening? What lives on disk? And I'm not sure. The names here aren't important. It's just to get the concept for a moment, which is on the system on this GlobaLeaks node, we have files that get stored, which are files, comments, which are messages, which everybody who's a party to this tip or a party to this submission can read, and messages which are intended to be private between a single recipient and the whistleblower. Okay, and these are the new constructs that we're introducing here. These are the new data structures. Okay, so at a technical level, what actually happens when you connect to GlobaLeaks with a web browser, either the Tor browser or incognito session of your browser of choice? So after the application loads, we issue a challenge. The server issues the challenge, sends the public keys of the intended recipients and a salt to the user's browser. The user responds with a challenge, CA, which has, which is basically, it's a combination of a CAPTCHA. It's configurable, but it's configurable, but it's a combination of a CAPTCHA and a proof of work. So once the server determines that there's a human and functioning JavaScript in that client, in this session, it issues a token, and this token is going to live for the rest of the submission, the rest of the process, and it's going to live as T parameterized on these submissions to the server. So this is the initialization. It actually happens anytime a whistleblower connects, and if there are any problems with that connection, we can just revoke T and walk away. So this is the authentication of the session itself for the whistleblower. Now, when that whistleblower walks through the submission process, what's actually happening are two GPG keys are generated. Sorry, PGP keys are generated. I always mix this up. And the notation is a little funky here, but this is the private key of the whistleblower and the public key of the whistleblower, and this is so it's S for secret, but it's the private key for the session and the public key for the session. So the whistleblower's client generates two keys. The session key is actually this key right here, which he generates for the intended recipients of this submission. So once we've got this key, we encrypt using the session key. We encrypt files that he submits using the session key. Okay, the server's going to store these, and T is gone. There should be a T, whatever. After we do these, and actually what's interesting is this is happening in a web browser. So this encryption, so this key is generated in the session of the browser, and these files are actually encrypted. We upload them in the browser, we encrypt them in memory, and we send them. It's complicated. There's a protocol to stream this, and we can sort of do streaming data encryption in the browser. Interesting stuff, kind of complicated. Whatever. Okay, we've generated some keys. We can generate a receipt in the format I'll get into in a little bit, but we generate what we call the receipt key passphrase, which is RK, which is a hash of this receipt, and this hash is parameterized with a salt sent from the server, which was submitted earlier, and the receipt. So script is a hash function. It's a memory hard password key derivation function, actually, and we use it to basically extend and make it difficult to brute force the key space. Okay, so script is a function that you can force a user to compute for some amount of time. So if you want a 250 millisecond computation, you can force that with the right parameters in script. And so this is what we do, in the sense of if you want to try a receipt key, a receipt key, you have to spend 250 milliseconds computing that in a web browser. You can do it faster, and we're going to go into that. Now, once this content has been encrypted, once the files have been encrypted, there's a final step of uploading the whistleblower's key, a hash of this receipt key, and the submission session key, SKS. So the final step of actually creating a submission is uploading an encrypted package. So we have files, and we have the content that's going to let us re-access this submission. And what's interesting here? So this encryption of access public key lists, the access public key list, exists as session key exists as a. Oh, this is complicated. I love it though. So PKR, PKR2, PKR3 are the public keys that correspond to the offline private keys of the receiver. We issue a there's not a sub key, but it's a symmetric key that each one of these, there's a single symmetric key that encrypts the session key for this object, which is the session key for the whole submission, and it's issued to the intended recipients of this submission. Very simple. These guys have access to it. This session key, as I'm trying to point out, is what protects these files and comments. Yeah. Okay. Now, this is the data. This content is still the data stored on the server. This receipt has been stored offline, and these are offline. Now, it's important that we're storing the hash of RK because it allows us to authenticate the whistleblower in future sessions. So if the whistleblower wants to return to this submission, he needs to regenerate RK and submit the hash of RK to re-access comments and messages that are stored in the system. Okay, I'm not sure if actually you guys probably haven't been able to see this corner, but allora. So when a whistleblower wants to come back after maybe, so what happens is, a submission gets generated. The intended recipients review it. They get an email notification about, hey, something has been submitted. Take a look. Maybe they leave some comments. Maybe they review it and they delete it. They say, no, this isn't worth it. But if they want to see the whistleblower come back, the receipt that he was issued is going to have this hash. This guy is going to live, and this is the key for the whistleblower to return to the system. So when the whistleblower returns after generating a new access control token, uses the hash of RK to get back his encrypted messages and the encrypted session key of that whistleblower. With this content, he can decrypt. He can basically reconstruct what he originally had, which was SKW and the message he submitted. Ignore this. This is a mistake. Additionally, he can submit more. He can encrypt new files and new messages and have the server store them. So it's like you reconstruct the original state without this, with only the public key of the tip, with only the public key of the tip session, and you're back to where you started. Very interesting. Okay, so if this is the setup, if we're going to use this, we actually need to look at what that receipt, the format of that receipt, because if it's there's a requirement of entropy on brute forcing the key space that we have to look at. In the sense of right now, we use a 16-digit receipt, and we only use that to authenticate the recipient in the same way, but we actually, because we're not performing allora. Actually, it's not important. We're just going to talk about it in the abstract. So there's a couple different formats that we can use for receipts. The goal is to keep the receipts small, so that it's memorable and feasibly deniable, in the sense of if you write down 16 digits, you could pretend this is a credit card number. This is the same format as a credit card number, but if you have like a base 58 string, it's a little less obvious. If you have a hex string, if you're an artist or you're like your secretary, it doesn't quite, it's like why would you have this if you're walking out of a building with a USB? Well, if you're walking out of a building with a USB and a 16-digit hexadecimal string. So we got this thing, and we can actually look at the difficulty of computing, enumerating the key space. So if we're interested in understanding what makes a good receipt to issue to people, so they don't have to memorize much, they don't have to write down much, and it's resistance to an attacker, we can just analyze the entropy and the difficulty of enumerating the key space. So this is this graph, and basically the parameters we're using for scrypt are not so important, but the output is this function uses 256 megabytes of memory. It takes about 250 milliseconds in JavaScript to compute one hash. In Python, using a native implementation, you can do it in 17. You can run it at 17 hertz hashes per second. And I think from what it looks like, from the way the ASIC industry, the ASICs compare, maybe you can run an ASIC at 10 kilohashes a second, in the sense of you can compute 10,000 outputs of scrypt in a second. So if you were a nation, or maybe let's stick with a nation. If you're a nation and you're interested in a GlobaLeaks node, and you've taken that server, how much money, if you spend $15 million, you produce 50,000 ASICs that run at 10 kilohashes a second. This is how long it takes to enumerate the key space. And so basically, from my point of view, this is, we basically have to use something that requires more than 33 weeks to enumerate the entire key space. Because once you've enumerated this key space, all of the input, all of the inputs for data encrypted with the whistleblower's key. So you can go back and read the comments of submissions, and you can go back and read the messages. So you can go back and read the metadata. You still can't actually access the files, because we never intended for the whistleblower to have access to the files after they were encrypted. But if you if you go and grab a receiver, if you go and grab one of these journalists, and you get you take their private key, you can come back through and get the files, the comments, and the messages. Okay. This, though, is resolved with a hammer. You just destroy the hard drive, and this is no longer a problem. Okay. So basically, this is the new system. It's described online, and we've implemented most of it. And okay, it does. It's actually, I think, quite modest in its goals, but I think it accomplishes them well. Now, there's a couple side notes, right? We can accomplish this adding of new users to sessions simply by adding the user's public key to the tip session key. Once somebody approves the request, we can run all of the logic, all of the JavaScript for recipients in a in an application that lives on a desktop environment. So it's just a wrapper for JavaScript. It's just it's a native WebKit environment. So it's just a V8 driver that lives that runs natively on your laptop instead of loading from a website. And there are some interesting there's some interesting API standards that we are waiting for larger compliance across browsers to increase the speed of our implementation. So the WC3 has a candidate recommendation for a web crypto API that we are waiting for to basically, native AES, and I think there's GCM, there's a stream cipher GCM that's much faster that may become a standard across all the browsers, which would let us increase the speed of file upload, which would be great. Side notes. This is the system. If you are interested at all in contributing to GlobaLeaks, if you're interested in learning more about the system, if you're interested in running, if you're interested in working with us, either come to the OFTC IRC network and join the channel GlobaLeaks. We have email, there's a website, there's a GitHub. This project lives on GitHub right now. And this is my fingerprint, and I am Cynic on OFTC. I'm not sure how much time I have, but happy to answer any questions. And thank you guys. It's kind of a funky little environment, but thank you. Later. Fantastic. Maybe. I think there's one year. Oh, grand.
All right, so I came in late, for which I apologize, and missed most of the actual stuff about JavaScript Crypto. But
okay.
I'm curious, have you had a chance to talk with Nadim Kabaisi about his PhD thesis?
No.
He is working on verifiable JavaScript and a compiler to do that, to do a lot of the nasty verification work for you. And the paper's not out yet, but GlobaLeaks is easy to remember. I can poke you. I can send a copy your way
that would be
when it finally comes out. I'm super excited about it. So.
That's great. Yeah, we for running JavaScript in a browser, there's all sorts of funky stuff. I think it's SNI, which is SNI. No, that's for TLS. But there's also like a hash-based verification for external CDN. So you have some content of maybe an application, and you store the hash of that application next to the JavaScript file that you load in your HTML, and like. It seems like maybe you could do this in GlobaLeaks use case, but that first, once you hit that server, the index page that you download is going to be totally determined by that server. So you're trusting the server on first use. But if it's if we generated a Chrome application or something, okay, maybe we could get around trusting this JavaScript in the browser, and and it's something, you spend a lot of time working on, and it's kind of a crapshoot. So thank you guys. I'll throw,